Hello, we are MSD Team P22414, Soil Indoor Toilet-Based Manufacturing. Our customer is a nonprofit organization in Haiti called SOIL, which stands for Sustainable, Organic, Integrated Livelihoods. One of SOIL's main activities is producing sustainable, or dry, toilets and providing them to areas that have no running water for flushing toilets. They then provide a collection service to replace the waste-filled buckets with new, clean ones. Currently, SOIL produces these toilets by sculpting concrete onto a wire mesh by hand. However, they want to ramp up their production, so they need a scalable manufacturing process to produce toilets quickly, cheaply, and repeatably.
We developed a few concepts for possible manufacturing processes and selected one to move forward with based on several key criteria including product cost, manufacturing time, and resource availability in Haiti. We decided that the best process would be a fiberglass mold that concrete could be poured into rather than sculpted by hand.
To construct this mold, we first developed a CAD model of the toilet in Fusion 360. This model was changed from previous teams' designs to include draft angles that would aid in removing the mold. We split the model into 10 pieces, which we 3D printed in RIT's makerspace, the construct. We referred to this 3D printed toilet as our proof, to be used to construct our fiberglass mold. These 10 proof pieces can be assembled in different configurations to be used as forms for each mold component.
We constructed our fiberglass mold in 5 components, 2 external pieces and 3 internal pieces. We cut fiberglass cloth to size for each mold component and laid up 5 layers of cloth with epoxy for each component. We added flanges to each piece so that the whole mold could be pinned and clamped together rigidly. We also created a plywood fixture with the shape of the bottom of the toilet cut into it, where the mold could sit. This keeps the inner and outer mold pieces aligned with one another.
When we poured concrete into the mold, we coated each component with oil to help separate the concrete toilet from the mold once the concrete cures. We assembled the mold in the fixture, complete with clamps and pins. Once the lower half was assembled, we mixed up some concrete and poured it into the mold. Then we attached the upper half and poured the rest of the concrete in. We used a palm sander to vibrate the concrete down and remove air bubbles. We let the concrete cure for a few days, then we removed all the pins, clamps, and fixture so that we could remove the mold components, revealing a concrete toilet.
The remainder of our time will be spent iterating on our design to improve our concrete pour process and the quality of the final product. At the conclusion of our project, we will have a full toilet that can be tested and used, and we'll have a complete set of designs and work instructions that we can send to SOIL in Haiti so that they can integrate our designs into their current manufacturing process. Furthermore, we will be able to send down our 3D printed proof and completed mold to help speed up the process.